so the lesson that we're moving on to now, it's on page 407 of your student workbook, and it is lesson 6. So what we've done is we finished fundamental counting principle and permutations, and we finished combinations. So they tack on this one last lesson, and the reason why they put this one lesson is because when we were doing the previous lesson, lesson 5, you knew that all the problems were combination problems, right? When I taught you a permutation lesson, you knew all your homework questions were going to be permutation questions. This now is going to be a combination of the two. Can you look at a problem and figure out, is it a fundamental counting principle or a permutations, or is it going to be the combination problem? Can you figure and differentiate between the two? And then what you're going to actually see is some of the problems that you'll actually get are going to be a combination of both. It's going to have a permanent and a combinant, and you'll be able to recognize those. Okay, this is the review, and on this review, the majority of the stuff, so from here to here, this was permutations. So the fundamental counting principle is a permutation. Factorial notation is a permutation. NPR, or N permute R, this is the formula for permutations. When we have permutations with repetitions, so the word rows, remember? No, Ross. This would be, if you want to do the example like this one, so this would have been the word Ross. That's a permutation with a repetition. If I said how many arrangements four-letter arrangements can be made from the letters in Ross, you would have said, okay, well, there's 4 letters total, and then you're going to divide it by the repeats. So we're going to be reviewing this today and making it more complicated. And then the combination is just this guy here. So combination. Couple of things about combinations. There's actually 3 different ways that you could write a combination, and I haven't talked about this way yet. So N choose R, or it could be written in a bracket. So sometimes on a test, on the diploma, what they've done to students before is they just said a bracket 10 and 2. And then students need to realize or recognize that if you see that, that is going to be a combination. It's always the top value is the N, and this is my R. So it would be, I have 10 items, and I'm selecting or choosing to arrange 2 of those items. Okay, so that would be a combination, 10 choose 2. And then whenever we have a combination, algebraically, it's identical to a permutation, except they have the R factorial in the denominator, but you will be provided with this on your exam and this on your exam. This one is not provided. Okay, what we're going to do for class example 1, so this is really going to show like when you can do these types of questions that you get this. Now, this would be new though, because there's repetitions, and I'm going to introduce restrictions as well. I'm going to show you 2 different ways to solve each one, how I would do it, and then how your book does it. And you can choose whatever you're more comfortable with. How many arrangements of the word copies can be made under each of the following conditions? So whenever we have the word arrangements, we're dealing with a permutation. Okay, whenever we're arranging letters in a word, it's going to be a permutation problem. First thing you do is you count up copies. And you say, okay, that would be 1, 2, 3, 4, 5, 6, 7. So let's write copies as 7 letters. If you were to arrange the letters in the word copies with no restrictions, okay. So how you would do that is you would say poppies has 7 letters. So there's a couple different ways that you could have done it. So 1, 2, 3, 4, 5, 6, 7. And 7 went here, 7 letters to choose from. 6, 5, 4, 3, 2, 1. So that would be 7 factorial. But then we must always divide by the number of repeats. And in poppies, there are 3 P's. So there's 7 letters total in poppies, and then you're going to divide it out by those 3 P's. So this is how you would deal with the arrangement of the 7 letters. And then you always say what the repeats is what you divide by. So 7 factorial divided by 3 factorial is 840 different ways that the letters in poppies could be arranged. And that's taking into account that there's 3 P's. If each arrangement begins with a P, okay, I'm going to show you how I would do it and then how the book would do it. Poppies has 7 letters. So I'm going to do 1, 2, 3, 4, 5, 6, 7. Okay. So poppies has 7 letters, and they want it to begin with a P. So I'm going to say, okay, I'm going to put a P down here. How many P's were there in the word poppies? Like, how many P's could I choose from? What do you guys think? 3. There's 3 P's total to choose from. So I'm going to put a 3 there. Okay. Then, once I place one of those 3 P's, I say to myself, okay, how many letters do I have left? I've got 6 letters left to go there. 5, 4, 3, 2, and 1. Then we've got to account for the repeats. So just dealing with this would be 3 times 6 factorial. Do you guys agree with that? Because there's 3 P's to choose from. And then there's 6 remaining letters. So it's 3 times 6 factorial. What you divide that by is always by the number of repeats. So the number of repeats would be, there's 3 P's in poppy. So that would be 3 factorial. Okay. Then what I'm going to show you is the book doesn't do it this way. So I'm going to show you what the answer for the book is. Let's clean up something in here. So let's rewrite 3 factorial because we know that 3 factorial is 3 times 2 times 1, right? So I'm going to write this as 3 over times 6 factorial all over 3 times 2 times 1. And then I'm just going to cancel these 3's. And so it is 6 factorial divided by 2. And the reason is the workbook, when they do this question and you were to look at the answer, they would say it's 6 factorial divided by 2, right? So they would just give you that answer. And I'm going to show you how they got their answer. Okay. And then you could, like I said, you choose which one you prefer. Okay, for all of these letter questions, I like setting up the number of arrangements of letters. And then I like saying there was 3 P's to choose from, right? And then I take care of that there was repeating P's down here. How your book does it is as follows. I'm just going to draw a line here. Your book says it has to start with a P. So they kind of take that out of the pool. This is how your book does it. Okay, so it starts with P, they take it out of the pool. Then your book says that there would be 6 letters left over, which is correct, right? If you start with a P, they took it out of the pool, so then they did 6 here. 3, 4, 5, 6. So then they said, okay, if that P is out of the pool, there was 6 remaining letters up here. So they did the 6, 5, 4, 3, 2, 1. And they got 6 factorial. Do you know what they would divide it by, though? How many repeats would be here? How many repeats would be in this section if one of the P's is out of the pool? There would be 2. So this is how your book does it. 6 factorial over 2 factorial. Okay? Versus how I do it. So I'm going to show you both ways, and then you pick which way you like. And then either way, we get the exact same answer, and we would both get an answer of 360. And then after you guys can tell me which way do you do, right? It's whatever way you want. Okay, so let's look at this one. If the first two letters are P's, so the way I do it, Poppy has 7 letters, I'm setting up 7 stages. So 1, 2, 3, 4, 5, 6, 7. They want the first 2 letters to be P's. So they want a P here and a P here. So how many P's do I have to choose from over here? In Poppy's, how many was there to choose from? 3. So I would put a 3 here, and then Isosa, how many P's would be left here? 2. Okay, so B says, oh no, sorry. Yeah, we did B. Okay, C says if the first 2 letters are P's. Okay, so P and P. This stage here, Poppy's had 7 letters, and I just placed 2 of them. So I would have 5 remaining letters to go there. 4, 3, 2, and 1. So I would multiply, this would be my numerator, and then you always got to divide it by the number of P's. So I would say, okay, it would be 3 times 2 times 5 factorial, all over the number of repeats, and the number of repeats is 3 factorial. Okay, and then what I would do is I would say, okay, 3 factorial is the same thing. I'm just going to erase this. I'm going to put 3 times 2 times 1. Okay, so I'm going to erase 3 factorial, and I'm going to say, well, 3 factorial, I know that is 3 times 2 times 1, and then the 3's would cancel, the 2's would cancel. What I would be left with is just 5 factorial. Your book, if you're going to look at how your book does it, they're just going to write 5 factorial is how your book does it. Now, I'm going to show you how the book would do it, okay, for this question. And then you guys decide. So the book says the first 2 letters are P's. So they're going to do P, P, and they're going to take that out of the pool, is how your book does it. And then what your book would say is, okay, Poppy's had 7 letters, and you took out 2 P's, so that's 5 letters left over. 1, 2, 3, 4, 5. So 5, 4, 3, 2, and 1. And then in here, the way the book does it, is there any repeating P's in this section? No. So the book just says, if I take those 2 P's out of the pool, this is what I'm left with, and they just get 5 is how they do it. Versus I set up the 7 stages. Okay, let's do D. So D, if all of the P's are together. Okay, if all the P's are together, I need to put them on one disc. So I'm just going to take out those P's. And then I would have a disc with an O on it, a disc with an I, a disc with an E, and a disc with an S. 1, 2, 3, 4, 5, 6, 7. Okay, so the way I taught you guys to do these disc questions would be, how many discs do you have total? Which would be 1, 2, 3, 4, 5 discs. Then what we had to do, if we were doing it there's sort of two ways you can do it from here. 5 discs. There's 3 P's on this disc, and it doesn't tell us the arrangements. So I could technically do this 3 factorial here, right? Because there's 3 of them. But then I just divide it by the number of arrangements anyways. Or sorry, the number of repeats. And there was 3 repeats. So 3 factorial. So this actually ends up just canceling. And your answer is just 5 factorial. Right? Some students would say, Mrs. King, well, do you even need to do that 3 factorial? Because P, and P is going to be the exact same thing as if you switch these 2 around, right? So you're right. Because these are 3 of the same letters, I technically don't need to write 3 factorial and then divide it by 2 factorial. But the answer for this question is just 5 factorial. Okay, so the answer is 5 factorial. 5 factorial is 120. Okay, how did your book do this question? Your book grouped the 3 P's together and kind of said, I'm just going to like take those out of the pool. Like those are going to be together out of the pool. And then your book said, or sorry, your book grouped those together. So your book said, like, let's group that together. And then they had 1, 2, 3, 4 more stages. And they said there's 5 stages total. So your book just said, if those 3, I shouldn't have drawn that line. The book kind of looks at the P's together as 1 stage. I just put it on 1 disc. Okay. And we're going to do one in the homework together. That's very similar to this. If the first letter is P and the next one is not a P. Okay, so I'm going to show you just how I would do this one instead of how the book does it because I think it's more confusing. So poppies has 7 stages. So I'd say, okay, the first letter is a P. They want a P here. Renee, how many P's are there to choose from? 3. So I'm going to say that there's 3, the number 3 would go there. The next one is not a P. So then I'd say, okay, not a P. Maria, how many letters are not P's? 4. Yep. So there's 4 letters to choose from there, right? So this one's a P. This one is not a P. So I just dealt with my restrictions. There's 3 P's to choose from, and that guy's not a P. And if you want, not a P would be this. It could be an O, an I, an E, or an S, right? So there was 4 letters to choose from there. Then what I would say is okay, those are my only 2 restrictions. That's a P, that's not a P. How many letters are left in my pool to go here? So you'd say there were 7 letters total, and I just placed 2. So there would be 5 letters to go here. 4, 3, 2, 1. So if I was doing this question, I would say it's 3 times 4 times 5 factorial. And then I would divide it by my repeats, which is, there's 3 P's. So 3 factorial. Okay, and then, does anybody have what that is? So 3 times 4 times 5, calculate your numerator and divide it by 3 factorial. What was it? 240. Okay, do you guys want to see how the book would have done this one? Or are you guys comfortable with the way I do it? Okay, let's just keep it that way. Because then when we do the homework question, I'll do one with you. I'm only going to show you my method. We're always going to set up the number of arrangements in the word, even if they're repeats. Because I deal with my repeats down here, right? Okay, so that's class example number 1. Let's do class example number 2 and number 3, and then we'll do a homework question. of 5 girls and 7 boys, and we're making a committee. If we are doing a committee, Brenna, is this going to be a combination or a permutation? It is going to be a combination. Words, making words is always going to be a permutation. You guys are making committees, you're doing a combination. They want the committee to be made of 2 girls and 3 boys. So a committee is to be formed consisting of 2 girls and 3 boys. Determine the number of ways we could choose the committee of 2 girls and 3 boys if there are no further restrictions. So no further restrictions. They want 2 girls and 3 boys, is what they want. A committee is to be formed consisting of 2 girls and 3 boys. So now let's figure out the number of combinations of selecting 2 girls, the number of combinations of selecting 3 boys. Let's multiply those together and we've got our combinations with no restrictions. So 2 girls, there's 5 girls to choose from, and we're going to select 2. The boys, there's 7 boys in the class, and we're going to choose 3. So this would be 5 choose 2 times 7 choose 3. Cyril, what did you get?
350.
350 is the answer. You might want to write like, for sure, you're going to see this question, like this type of question. Exam question. Okay, Johnny, the principal's son, must be on the committee. Okay, so it's a 5-person committee. So Johnny must be on the committee. So Johnny and how many girls did they say are on the committee? 2 girls. So Johnny and 2 girls, and it's a 5-person committee. So Gabby, how many boys are left if Johnny gets a spot?
6 boys and 2 spots.
Yes. Yeah, it was like they want 3 boys on the committee, you guys, but Johnny's a boy. So now there's only 2 boys left to pick from or to choose. So 2 boys. Okay, how many ways of there are selecting Johnny? 1 way. There's only 1 way to select Johnny. Johnny, you're it. You're on. So he's on. 2 girls, we did that right here. There was 5 girls to choose from, and we're choosing 2. Now, this one is a little bit trickier. It is not going to be 7 choose 2. Does anybody know what it would be? It would be 6 choose 2. The reason is there are 7 boys, which is correct, but one of those boys is Johnny. So Johnny's already on, so now I've got 6 boys left to choose from, and I'm choosing 2 of them. So I'm going to give you a question tomorrow, and I'm going to say it's going to be a committee question, and I'm going to say this person is on the committee. So you put that person on, and then you've got to subtract that person here. So this answer should be 150. Okay, C. The twins, Peter and Paul, cannot both be on the committee. So the easiest way to do this question, I believe, is the complement. So the complement of these guys cannot both be on the committee would be, what's the opposite of they both cannot be on the committee? They're both on the committee. So the complement of Peter and Paul can't both be on the committee is how many ways can Peter and Paul be on the committee? So it's going to be the number with no restrictions minus the complement of Peter and Paul cannot both be on the committee is Peter and Paul on the committee. So Peter and Paul on the committee. Okay, no restrictions would be, did I say for no restrictions? Okay, we calculated no restrictions up here, right? Do you guys agree with this? No restrictions, because remember it said it wanted 2 girls and 3 boys. So no restrictions would have been 2 girls and 3 boys. We did the math right here, 350. Minus. Okay, Peter. Oops. He's on, and his brother's on. And how many girls are on this committee? 2 girls. And how many boys would be left to choose from if Peter and Paul are on the committee? I got 1 boy left. Okay. So you're going to say 350 minus. Okay, how many ways are there selecting Peter? There's only 1 way to select Peter. How many ways are there selecting Paul? There's only 1 way to select Paul. How many ways are there selecting 2 girls? There's 5 girls to choose from, and we're selecting 2 of them. Okay, now we got to figure out the boy, and the boy is a little bit of work because I had 7 boys to choose from, but I've already placed Peter and Paul. So how many boys do I have left to choose from? This 1 boy. How many is left in my pool if Peter and Paul are already on the team? From 7. Anybody know? I had 7 boys. I selected why don't 6 choose 2? I had 7 boys. I selected Peter and Paul. That means I have 5 remaining boys to choose from, and I'm choosing 1 of them because I'm only choosing 1 boy left. Remember, you need 3 boys on the committee. Peter and Paul are 2 boys, so I only need 1 boy left. There was 7 boys, but Peter and Paul are on, so there's 5 boys to choose from, and you're choosing 1 of them. What do you guys get when you multiply this together? 5 choose 2 times 5 choose 1. 50. So 350 minus 50 gives you an answer of 3. So 300 would be there. Okay, this question here is our last class example. And this class example, there's a permutation in here and there's combination. So this is like a combined problem. Okay, David, Stephen, and Helen were trying to answer the following homework question. So this is the homework question here. The students in a school band have practiced 5 popular songs and 6 classical songs. So the band knows 5 popular and 6 musical. For the concert, they're going to choose a program consisting of 3 popular and 2 classical. So let's write this. Their program is going to consist of, they need to select 3 popular and 2 classical. 3 popular and 2 classical. Okay, so do you guys know they're choosing a program consisting of 3 popular songs and 2 classical songs? Do you know if this would be, like if you were choosing 3 popular songs from 5, is it going to be 5 permute 3 or is it going to be 5 choose
For questions as if the order matters.
Yes, okay, so Ignore that for now. We're gonna deal with that at the very end. We're gonna deal with that at the end. But if I just said, okay, you guys, you know 5 popular songs and 6 classical songs. You need to, we're gonna choose to make a program and 3 popular are gonna go on our program. Do you think it's a permutation or combination? What would you do? Because both of these are the exact same, but Stephen set it up as a permutation and Helen set it up as a combination. So you're basically asking yourself, at this stage, does order matter? No, it does not, right? If you just know 5 popular songs and you're to choose 3 of those songs, the order right now doesn't matter. So how many ways you could choose 3 popular songs out of 5 would be, you know 5 total, and you're gonna choose 3. Then we need an and. Now we need to, on our program needs 2 classical. So 2 classical would be, we know 6 classical in total, and we need 2 of them. So that would be 6, choose 2. Okay. This is going to give us the number of combinations that could go in the program. But then what it says is what Olivia was saying, is it then says, if the order of the composition matters. So this is how we choose how many classic or how many popular songs. This is how we choose how many classical songs. Then what they're saying, from the 5 songs that we have, it matters which we're going to play first, second, third, fourth, or fifth. So then from there, then they're saying order matters. So we've got 5 songs to choose from, and it matters what song we're going to play first, second, third, fourth, and fifth. We've got 5 songs to choose from to go here. Once we have our selection, then we've got 4 here, 3, 2, and 1. So the answer, because we're not just selecting songs, they've tacked on that word, the order of the composition matters. The answer is 5 choose 3 times 6 choose 2. So this times, as soon as they say order matters, because there was 5 songs, the order of those 5 songs matter. It becomes a permutation at the end. Once we have our 5 songs selected. So this is getting our 5 songs, choosing our 5 songs, and then this is arranging the 5 songs. So this is how you would do this. And at the end of the day, if you type that in your calculator, the answer should be 184. Different ways that we could make a program with 3 popular songs and 2 classical songs if order matters of those 5 songs. Okay. So once you do these questions on the homework, you should, like, this is the one you really want to pay attention to that you understand this. Okay, here's your homework. So let's get this circled. And then we're going to do a couple questions together. So let's do start number 1 together and number 3 together. Okay. This one is a little bit confusing for number 1 because they have the word choose. Some students would see this and they'd be like, oh, this is like a combination. But what you have is you have a squad of 11 basketball players is to be chosen from 17 available players. in how many ways can this be done if Colin and Daryl must be selected? Okay, so we need to make a squad of 11 people. So 11 people. Colin and Daryl. And if we need 11 players, how many left do I have to pick from, basically, if I just place these two because they have to be on the squad? My 11 just went down to what? 9. Okay. So there's one way to select Colin. There's one way to select Daryl. I have 11, or sorry, this would be, sorry, we're choosing, yeah, so this is going to be a combination. There's one way to select Colin, there's one way to select Daryl. I have 17 players to choose from. But now, because Colin and Daryl are already on a team, that goes down to, now I've got 15 players to choose from. And I am choosing, do you guys know what this number would be? 9. Yep, because 11 minus 2 is 9, because Colin and Daryl are on. So it would be 15 choose 9. Okay, Jeff and Brent cannot be selected. If ever you say they can't be selected, it's easiest to do the complement, right? So this would hopefully, when you can't select something, what you want to do is you want to say what's the complement of that. So the complement would be Jeff and Brent are both selected. So it would be number of no restrictions. Okay. No restrictions. There was 17 players available, choosing 11 of them. That's no restrictions. Minus the complement of Jeff and Brett not being selected is select Jeff and Brett. Right? So that would be this exact scenario. So if Jeff is on the team and Brent is on the team and we need 9 remaining from 15 to choose from, is how you do this one. You are not doing number 2. Let's do this one. So let's do tattoo the way that like I taught it, which will be very different from how your book sets it up, right? So how I would do this one is I'd say, okay, I give you the word tattoo. 1, 2, 3, 4, 5, 6 letters. So count up the letters. You know that whenever we have letters, it's going to be an arrangement. It's going to be a permutation. Begins with T. 1, 2, 3, 4, 5, 6. They want it to start with a T. Kenzie, how many T's can go in that first slot? 3. So there's 3 T's that could go there. Then what I would have done is I would have said, okay, it begins with a T, so I took care of that restriction. I had 6 letters, I just placed 1. So I've got 5, 4, 3, 2, and 1. So your answer would be 3 times 5 factorial, and you must always divide out your repeats. So the repeats in tattoo, there's actually a couple things happening. Brenna, what are the repeats in tattoo? So 3 factorial for the 3 T's, and then she said 2 O's, that would be 2 factorial. Make sure that that's in a bracket. Can you guys type that into your calculator for me? And what would you get for this one? 60 or 30? You guys double check. You're saying the answer is double check, you guys. I get that it should be 30. And Adriel, you punch this in. Are you getting 30? Okay. So answer should be 30. The next one. Let's set up tattoo, 6 letters. 1, 2, 3, 4, 5, 6. Begin with 2 T's. T goes there and T goes there. So I had 3 T's choices to go there, 2 T choices to go there. There are 6 letters and I just placed 2 of them. So I would have 4 remaining letters, 3, 2, and 1. And then you always got to divide out the letters. So this would be my numerator, 3 times 2 times 4 factorial. All divided by 3 factorial, 2 factorial. Some of you would see actually, 3 times 2 is 6. And what is 3 factorial? 6. So some of you would be like, oh, I'm not even going to punch that into my calculator, right? Because that's 6 and that's 6. So some people would just punch in 4 factorial over 2 factorial. And that's how your book has it done, 4 factorial over 2 factorial. Okay, begins with 3 T's. So, and it doesn't say the T's have to be together, so I'm not going to put it on a disc, right? It just says it begins with 3 T's. So T, T, T. There's 3, 2, and 1 left. After I use up, there were 6 letters in tattoo and I placed 3. So 3, 2, 1. So this should be 3 times 2 times 1 times 3 factorial, all over the repeats. There was 3 T's and there was 2 O's. 3 factorial and 3 factorial would cancel. 2 factorial is just 2. So that would cancel. And I'd be left with 3 as an answer. Okay, D is the one that should give the most thought, and we didn't do D yet. Begins with exactly 2 T's. So, I'll show you what I would do for this. 1, 2, 3, 4, 5, 6. Okay, exactly 2 T's would be that. If you guys have exactly 2 T's, what could this not be basically? It can't be a T. Do you guys agree with that? So if you're starting with exactly 2 T's, then what that means is this could be, it just can't be a T. So exactly 2 T's. Okay, so let's set it up exactly 2 T's, and then this guy would not be a T. Which could be, it could be an O or an A, basically. Okay, so exactly 2 T's would be, there's 3 T's to go there, there's 2 T's to go there. Not a T would be not a T. So how many are not T's? 3 to go there. Okay. Then over here, I would say, do you guys know what number I'd write here? Think about how many letters have been placed at this point. So I placed 3 letters. There are 6 letters to choose from. And I'm going to subtract, I placed 3 of them. So 3, 2, 1. And this would give me, so 3 times 2 times 3 times 3 factorial, all over my repeats, which is 3 factorial, 2 factorial. That would cancel. and 2 and 2 cancel. This would give me 9. So we looked at it a totally different way, but in my brain, like, this makes sense. If you guys want me to explain later on how I looked at it. Okay. So go through and get as much done as you can from this homework, and then I will hand you out